Alright, welcome guys, nice to see you back again, and now we're going to be looking at how do we actually name acids and bases. A lot of this stuff that we've been doing has been quite intuitive, because over the years that you've been doing chemistry from year 7 to now year 12, you've been coming across examples of acids and bases and you've sort of memorized them, but there are actually rules that we can use to name them, and those rules have been put forward by the International Union of Pure and Applied Chemists, which is IUPAC for short, and they are in control of making all the rules for naming organic or inorganic compounds, and we're going to be learning those later on in our course in year 12. They are also responsible for approving names for newly discovered elements, etc., and of course measuring and having the standards at which are displayed on periodic tables. So let's have a look here, because it says in this first dot point the correct nomenclature. We've looked at the properties of acids and bases. Now we're looking into the nomenclature of the naming system. So nomenclature just means to name them. What are the rules? So let's check it out here. Alright, so let's start with acids. Right? Acids are important hydrogen containing molecular compounds, and we have some rules. Now I've got lots of examples here of acids. I've got hydrochloric acid there, sulfuric acid. Now I've also got this one here, which you probably haven't seen before. It looks very similar, but let's have a look. We've got a group there, SO4, which we know as sulfate. And then we have SO3. SO3 is actually called sulfite. So we have different polyatomic ion name here. We're going from a sulfate, you take one oxygen down, you become a sulfite. That means when it makes an acid, it's a different type of acid. So when the sulfate joins up with a hydrogen, right, we call it sulfuric acid. So the first thing with these is these are called oxo acids, right? Oxo acid, in other words, containing oxygen and hydrogen. If the central atom can form two different oxo anions, right? So if it can form, so remember an anion is a polyatomic ion that has a negative charge. So this central atom here, sulfur, can form SO4 2- and SO3 2-. So therefore it has the ability to form two types of oxo anions. Then what you do is the one that has the more oxygen atoms is called ate. The one that has the lower number of oxygen atoms is called ite. So this is called sulfate and this is called sulfite. Okay. We can also have the same happening with nitrogen. We can see here we've got nitrogen. I've only got the nitrate example here, but you can have nitrate, which is, NO3-, but you can have nitrite as well. Okay. Then you can have the same with phosphate. So you have phosphate, phosphite. Okay. So this little rule here about if this central atom, sulfur, nitrogen, phosphorus, can make two or more oxo anions, then the first one with the most oxygen is ate, then we have ite. So that's just some prefixes. But when we put them into water, it makes a different types of acid. So an ate will make an uric acid, right? So an ate will make sulfuric, I should say an ic acid, not really. Have I said it on the next slide? Nope. I don't think so. Nope. So we've said an ate makes an ic acid. So nitrate makes nitric acid. Sulfate makes sulfuric acid. Right? So the sulfu, if I enlarge this now, right? The sulfu, that comes from the actual name sulfur, right? So we have sulfur. Now there's two different ways to spell sulfur. There's the American way and the British way. So if we look at the way this is spelt here, we can see that the first bit there, sulfur, and then we have the IC for the acid, right? So sulfuric. So 8 goes to ic, nitrate goes to nitric acid, carbonate goes to carbonic, Okay, so we've got that IC at the end. If we have an ite, then that goes to an us ending. So sulfite goes to sulfurous acid, right? So they're just little things to watch out for. There is a system there, but like I said before, you're not probably going to get tested on this in terms of, you know, a multiple choice question saying, what is the name of this acid? I mean, that's such a really basic recall question. Probably won't happen, but you never know. All right, now these acids here are quite different. You can see now that we've now got hydrogens attached to the anions. So previously we had sulfate, and sulfate was SO4 2-, but now we've added a hydrogen to that, which means now the charge has gone down to -1 instead of -2, and so this is called a hydrogen sulfate ion. And we can do the same for carbonate phosphates, right? The cool thing here is that phosphate, because phosphate is normally PO4 3-, it can accept one hydrogen, and that goes down by 1, or it can have 2 hydrogens, and then we go down another one. So phosphate has the ability to form 2 different hydrogen ions, I should say. So what are these? Well, these are called amphiprotic ions, right? What does amphiprotic mean? Well, I'm glad you asked, because I'm about to tell you. Amphi means to change, doesn't it? So amphi is amphibian, amphibious. So that amphi prefix means it has the ability to change and do 2 things, right? An amphibian lives on land and in water. Protic, of course, is just protons. So what this means is that they can donate or they can accept protons. And we're going to look at this in more detail in later videos. But because of that, it means that now we have to change the way in which they name the acid, right? So here we have a hydrogen sulfate ion. This is a hydrogen carbonate ion, okay? And then we have, with phosphate, we can have 1 hydrogen, so it's monohydrogen phosphate, or we have dihydrogen phosphate ion. So these are acids that have the ability to lose that H+, because remember that's the definition of an acid that we started off with. And so this here affects the naming where it has these hydrogens in there. Okay? All right, what about bases? Well, as you know, it's all about the base, right? So let's do bases, because bases are really a lot simpler compared to the acids. Now, hydroxide bases are those that have a hydroxide ion, okay, and they're the ones that we said previously bases release that hydroxide ion into solution. And so we name the cation first, just like in any naming system. Remember when we do ionic compounds, it's the cation first, then the anion. So if I had this one here, then of course that would be sodium, which is the cation, and then hydroxide, okay? If I had magnesium, then that's the cation, and then I have hydroxide. Okay, if we have the metal or the cation being multivalent, then we have to put Roman numerals in, just like we did when we did ionic compounds before. So if I had copper, right? Remember the copper and have 2+ or 3+. So I could have copper 2 hydroxide. So I'm doing the same thing there. So that would be CuOH2, right? Copper 2 hydroxide. What about carbonate bases? Well, we've seen previously that carbonates do react with acids, and therefore carbonates are an example of a base, right? They have either a carbonate group or a hydrogen carbonate. So we can have something like this, which is sodium. Whoops. We can have sodium carbonate, or we can have sodium hydrogen carbonate. Okay, and that's bicarb. Right, it's a common name. But we can also, with this one here, because it's got the hydrogen carbonate there, we name that as sodium hydrogen carbonate. So remember back here we had hydrogen sulfate. Well, this is to do with acids. Well, we can do the same here with the base there, hydrogen carbonate. Sometimes they they say sodium bicarbonate, which is a common name. So that's naming acids. So hopefully that makes sense. We looked at some rules, the IUPAC rules to name acids and bases. Most of them we've encountered before. There were some those new ones where we had sulfate, sulfite, and the 8s went to ic acid. So sulfate went to sulfuric, and then sulfite went to sulfurous. Okay, we had those little naming conventions. So look at those. Try and find some other acids out there like chlorous, hypochlorous, etc. All right, but that, you know, it may not be a question they ask, but who knows? You never know luck in this grand universe of ours. Hope that makes sense to you, and I'll see you in the next video. Right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.